Hello. Sorry I wasn't able to come see you guys today. Today is the 17th, and this is your lesson on parent functions and family graphs. So a family of graphs displays similar characteristics, much like people in your biological family. A parent function is the simplest function of the family, and I like to call that the OG family. At this time, make sure that your cell phones are off, that everything is put away, and that you are ready to take notes. You can pause the video at any time or rewind to catch up. So I have a couple of function families. I have the parent function. I have linear, absolute, quadratic, and cubic. And then on the back side of this paper, I have square root, cube root, reciprocal, exponential, and logarithmic. We've been focusing a lot of our time on absolute value, so that's where I'm going to start. The absolute value parent function that we know is f of x equals the absolute value of x. And with that stated, if you are going to generate a table, and you know how to do that on your graphing calculator, the function starts at 0, 0, and it goes 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and so on, or negative 1, 1, negative 2, 2, negative 3, 3, negative 4, 4, and negative 5, 5. It creates a sharp point and a V-shaped graph. Over here, these are the characteristics. Characteristics, we start with domain and range. So the domain, remember, we talk about it in east to west. So I might just write this up here. So north, south, west, and east extends in the west to east direction continuously. So I'm going to write all real numbers for the domain. Because it extends in the west to east direction. For the range, we're looking at north to south only, and we start out at 0, and our graph is only going up towards the north. So now you have a choice. You can write this as y is greater than or equal to 0, or you can write this like we've stated before, that 0 goes to infinity with a parentheses. Okay, so now something we have not talked about are the x and y intercepts. These are also characteristics. So we know that the west to east direction is our x-axis. It hits the x-axis at 0. The coordinate of this point is 0, 0. The y-axis is the up and down, north to south axis, and it also hits the y-axis at 0. So our y-intercept is also 0, 0. Now, this says the number of roots or zeros. Well, it only hits the x-axis one time. So roots and zeros refer to the x-intercept. So I'm actually going to draw an arrow that goes from here to here, because x-intercept means roots or zeros. And it hits the x-axis only one time right at that vertex. So there's only one of them. Okay? At this point, now, the end behavior. So as x approaches infinity, so let's look at this. So here's my x-axis, okay? And this is 0. And like in this direction, it's infinity. And then in this direction, it's negative infinity. As x values approach infinity, so going all the way to the east, what happens? Let's look at the graph. The graph is going up, right? It's going all the way straight up. So as I'm going this way, every point is getting higher and higher and higher and higher. So since it's getting higher and higher and higher without bound, it's going to infinity. And behavior on the other side, as x from 0 goes to negative infinity, so let's write negative infinity here. What's happening to my graph? Well, every point I go, it gets up, 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 so it's also going to infinity. And we know that this is a continuous graph because there are no breaks in it, and it's smooth, except for this point. It's smooth, there's no jumps, no hops, no skips. So that is absolute value. Now I'm going to go to linear. You can pause it, remember, at any time. The function family for linear is f of x equals x. That is the original parent function. To graph this, you're going to start, you can generate a table on your calculator. It starts at 0, 0, then 1, 1, 2, 2, 3, 3, 4, 4, just like our absolute value graph did. But the difference here is that it's going to go down in this direction and not back up like the absolute value. And that's because the characteristic of absolute value is you put a number in here and the output's always positive. So this is our linear function. It is a straight line. It's continuous in both directions. As far as I go east to west, so it's going this way to the east forever and then this way to the west forever. So remember, like, this would be north, south, west, east. So like this direction would be northeast forever. This would be southwest, because you say west and east in your description of it. Linear functions also, oopsies, I don't know why I got it all the way there. Linear functions are also all real numbers for domain. The range, because you say north and south in your description, like northeast and southwest, forever, it's also all reals. The x-intercept is very similar to the x-intercept here. That graph hits the x-axis at 0, 0. And the y-intercept is also at 0, 0. Okay. So the number of roots, well, there's one root here. Now, you know what? I actually have to change that. It's for x-intercept for the second one, because I didn't really pay attention to this when I was telling you the first time. Down here, it actually asks for the maximum number of roots. Now, that's interesting because this particular parent function only has one root. But if we were to translate this v all the way down, I'm just going to draw. You have to draw this. It could look something like this. And in that case, it could intercept the graph or the y-axis 2 times. So in that case, if we're looking for the maximum number of roots, this number should not be 1. It should actually be 2. Okay, so that's interesting. I didn't catch that until I went back up here. Anywho, so this is the same thing. This is the positive infinity. So as x0 approaches positive infinity, the graph is going up. So positive infinity, and this says the function, which is the green thing I just plotted, is going up. Okay, and then on the other side, as x is approaching negative infinity or to the west, so let's draw negative infinity here, the graph is going down. So, and therefore, this is a continuous function. There's no breaks or anything in that particular graph. Once again, if you need to stop this and move along in order to kind of catch up, you may. Quadratic. The quadratic function is f of x, our parent function. The OG function is x squared. So this one increases differently than linear. This starts out at 0, 0. It goes 1, 1, which is normal, but then it goes 2 to 4. So 1, 2, 3, 4. And it goes negative 2 to 4. So this function is a U-shaped graph. It's smooth, and it looks like a U or a smile. The domain of this function, so the smile will go on forever because the arrows point up, are all real numbers, just very similar to the absolute value. And since this vertex is at 0, this particular range is y is greater than or equal to 0, same as that absolute value function. The x-intercept at this point is 0, 0. And the y-intercept is the same, 0. Oops, sorry. It's hard to hold my cell phone and write at the same time, 0, 0. Okay. The maximum number of roots, I don't want to get tripped up on this. So the maximum number of x-intercepts, so that U shape could get translated down. So it could hit this wide part of the mouth, or the parabola, could hit that x-axis twice. So that's where the maximum number of roots, right now it's at 1. I could actually shift it up here and make it 0, but the maximum number of roots is 2. Okay, so as x goes to positive infinity, my green line is going up, 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 up. Positive infinity. My green line is going up. As x goes to negative infinity, my green line is also going up. And this is a continuous function. Okay, lastly, cubic. F of x equals x cubed. Okay, so I'm going to start out here, and I'm going to start at 0, because 0 cubed is 0. 1 cubed is 1. Negative 1 cubed is negative 1. 2 cubed is 8. So 1, 2, 3, 4, 5, 6, 7, 8. Oh, it's all the way up here. And then negative 2 cubed is down here. So it looks something like this. So pretty, like a disco graph. The domain of the function, well, it goes east and west forever. So that's, once again, all reals. Just kind of like our linear function kind of extends. And because it's not quite linear, but it looks, because there is a curve in there, there is a change. But the range is also very similar to that, where it goes up and down forever as well. So it's all reals also. Okay. The x-intercept happens right here at 0, 0. The y-intercept happens also at 0, 0. Okay. The maximum number of roots are zeros. Because this is a cubic function, you can generally have as many maximum zeros as there are in the power. So this is 3. You know how we had 2 here? That's why it was 2 here. This could have 3 because it could hit 1, 2, and then up here 3. So the maximum number is 3. The end behavior, as x approaches infinity in this direction, my graph is going up. So infinity to infinity. And then lastly, as x approaches negative infinity, my graph is going down, so it's negative infinity. And this is a continuous graph. All right, so I would like you to stop this part of the video, and if you have any questions or if you need to rewind or anything, now is the time to do so.